In this video, we look at investigating stretches and reflections. So first, we're told the graph of f of x is shown to the right, and it wants us to graph 2f of x over 2, and graph negative f of x. So let's focus first on the graph of 2f of x. So let's try to figure out a table of values for 2f of x, and then we can plot the x and y values, or the coordinates, from the table of values. So first, let's try to evaluate 2f of x when x is negative 4. So 2 times f of x, well, that's the same thing as evaluating f at negative 4 and then multiplying it by 2. So f at negative 4 is positive 4. If I multiply 4 by 2, I get 8. So I'm going to have a point at negative 4 comma 8. The same thing for 2f of negative 2. To figure out to evaluate 2f of x when x is minus 2, I can first evaluate the function f at negative 2, and then multiply that value by 2. So f at minus 2, if I want to do, so f at minus 2, f at minus 2 is 0. So this is equivalent to f at minus 2 is equivalent to 2 times 0, which is just 0. So I've got another point at negative 2 comma 0. I can do the same thing. When x is 0. So I can evaluate 2f of 0. Well, that's equal to 2 times the value of f at 0. The value of f at 0 is 3, so this is equivalent to 2 times 3, which is equal to 6. So I have another point at 0 comma 6. And same thing for when x is 2. 2 times f of 2, well, f of 2 is 1. So 2 times 1 is 2. And f at 4 is negative 2. 2 times negative 2 is minus 4. So now let's go ahead and we'll plot all those points. So negative 4 comma 8 is right here. Negative 2 comma 0 is here. 0 comma 6 is here. And 4 comma negative 4 is right here. So let's go ahead and we'll connect those points together, and we'll see what happened to the graph of f of x. Oh, I've also got 2 comma 2 here. So this is the graph of 2f of x. Now you might notice that basically what we did was, to get the y values of 2f of x, we took the corresponding y values of f of x we took the values of f at x and we multiplied them by 2. So what that means is that when x was negative 4, I looked at the value of f at negative 4, and I multiplied its y value by 2. So what that essentially does is you're stretching the distance between this point and the x-axis by a factor of 2. And you're doing that for all of the points. So that gives us the graph of 2f of x. Now, let's do the same exercise for f of x over 2. And we'll come up with that plot next. So when x is negative 4, f of negative 4 is 4. If we divide that y value by 2, I would get f of negative 4 over 2, which is minus 2. If I evaluate f at minus 2, I get 0. If you divide 0 by 2, you get 0. If we evaluate f of 0, we get 3. 3 divided by 2 is 1.5. So I get another point at 0 comma 1.5. If I evaluate f of x at 2, well, let's see, f of x at 2 is 1. 1 divided by 2 is 0.5. And if I evaluate f of x at 4, well, f of x at 4 is negative 2. Negative 2 divided by 2 is negative 1. So we can use this table of values and these coordinates to plot the function f of x over 2. Our first point is going to be here at negative 4 comma negative 2. Our next point will be here, here, and I have a point here, and lastly, my last point is here. So you can see that all that I did in this case was I took the y values of f of x at their corresponding x values, and I divided them by 2. So what that does is it actually compresses the function of f of x. So this is a vertical compression by a factor of 2. Or sorry, by a factor of 1/2. Vertical compression by a factor of 1/2. Now let's look at what happens for when we evaluate negative f of x. So for negative f of x, we're going to take all the y values at their corresponding, or we're going to evaluate the function f of x at their corresponding x values, and then multiply them by negative 1. So when x is minus 4, f of x is 4. So I can multiply 4 by negative 1, and I'll get that negative f of minus 4 is minus 4. If I take the x, if I evaluate f at minus 2, I get 0. 0 times negative 1 is 0. If I evaluate f at 0, I get positive 3. Positive 3 times negative 1 is minus 3. If I evaluate f at positive 2, f at positive 2 is 1. 1 times negative 1 is minus 1. And lastly, f at 4 is minus 2. Negative 2 times minus 1 is positive 2. So now we can use our table of values to graph negative f of x. Well, our first coordinate is negative 4 comma negative 4, which is down here. Our next coordinate is negative 2 comma 0, followed by 0 comma negative 3, which is right here. 2 comma negative 1. 2 comma minus 1 is here. And lastly, 4 comma positive 2. 4 comma positive 2 is this point right here. We can connect all those points together. And we can see, we can now visualize the graph, or we now graphed negative f of x. So this green graph is the graph of minus f of x. The beige graph was the graph of f of x over 2 as well. I should have labeled that. If you're producing multiple graphs on the same grid, you should always label your graphs. So the next question is, how do the graphs from A, B, and C compare to the graphs of f of x? So let's first examine A. A was actually here. Let's use a different color. A was 2f of x, and how does that compare to the graph of f of x? Well, like we already examined, we've taken all the y values and we've multiplied them by 2, which stretches the graph vertically by a factor of 2. So 2f of x is a vertical, is a vertical stretch by a factor of 2 of f of x. In B, we saw that f of x over 2 is a vertical compression by a factor by a factor of 1/2 of f of x. And in C, minus f of x, let's see how minus f of x compares to the graph of f of x. Well, notice that you have the same y values, except for you have the corresponding x value, we have the same y values except for they're negative. So what does that do? It reflects the graph of f of x about the x-axis. So negative f of x is a reflection of f of x about the x-axis. Oops, about the x-axis. Okay. Of f of x. Oh no, I already wrote that. Okay, we're good. So this makes sense. Negative f of x is a reflection of f of x about the x-axis. That makes sense. In the next video, we're going to look at horizontal compressions, stretches, and reflections.